In problem 9, you're dealing with an isosceles triangle, XYZ. They tell you that XY is equal to YZ. So when I label this, XY and YZ are going to be my equal lengths. And then if I plug in the expressions for each of these, XY is given with the expression x minus 1 quantity squared. YZ is given as the expression x squared plus 3x minus 14. And then ZX is given with the expression 3x minus 7. And we want to find all three of these lengths. So the first thing we're going to do here is take the known relationship, XY and YZ are equal to each other, and substitute in the corresponding expressions. So XY is equivalent to x minus 1 squared. YZ is equivalent to x squared plus 3x minus 14. So if we solve these, again, we solve this by expanding this binomial square. Remember, the expansion pattern for a binomial square is to square the first term, double the product of the terms, so x times a negative 1 is negative x, double that, we get negative 2x, and then square the last term plus 1. The right side of the equation isn't going to change at all, and what we can now do is just subtract an x squared from both sides, so those cancel completely. Let's move all the x's to the positive side, so add a 2x to both sides and add 14 to both sides. So we get 15 is equal to 5x. Divide both sides by 5 to isolate our x completely. We get x is equal to 3. That's not our answer, that's just the value for x that we plug in. And so we can find our answers by plugging this in. 3 times 3 is 9, minus 7 gives us 2 for the length xz. Here 3 minus 1 is 2, 2 squared is 4 for xy. And if we've done this correctly, we should get 4 for this length as well. So 3 squared is 9, plus 3 times 3 is 9, minus 14. So 18 minus 14 does give us 4. Confirms that we have our isosceles triangle, and so these would be the three lengths.